All right, so next thing we're going to talk about is not so much a discontinuity. We're going to talk about how does the graph behave at the very ends, or what we call end behavior. We've already kind of done this with parabolas and cubics when we were using our limit notation, saying, hey, as x was going to infinity, my y was going to infinity, looking at the ends like this and like this, vice versa, along those lines. But now we're going to do the same thing for rational functions. And there's actually 3 rules we need to know for rational functions to find the horizontal asymptote. So here we go. Rule number 1, and I'm talking about degrees. So the degree of the polynomial, which is always the highest exponent that's in the numerator or denominator. It's always the highest exponent to find the degree of the polynomial. That's why we worked on those when we're doing. If my degree are the same, I'm just going to write same. We're talking about degrees. Degree of the polynomial. If they are the same, it is a ratio of leading coefficient. Whatever, I can't spell coefficient. I can, but I just don't remember. All right. So let's look at an example. So an example of where the degrees are going to be the same. Let's do 5x squared plus 9x minus 13x cubed plus 4 over 26x cubed plus 5x squared minus x minus 17. All right. So we're going to look and we're got to figure out the degrees. So I'm going to look at the top and I'm going to look for my highest exponent. My highest exponent is 3 right here. So this is a polynomial of degree 3. On the bottom, my highest exponent is a 3. So that's also a polynomial of a degree 3. So in this case, they're going to be the same. My degrees are the same. So I'm going to take a ratio of the leading coefficients. Now, what you have to remember, the leading coefficient is not the coefficient directly that comes first. It is the coefficient that's in front of the x with the highest exponent. It's the number and sign. In this case, in the top part, it is this negative 13. So my horizontal asymptote, let's look at the ratios right off the bat. I've got a negative 13, my leading coefficient. X cubed, the leading coefficient, number and sign, which is a positive 26. So what this tells me, when I reduce this fraction, I've got a negative 1. Now this is just like a vertical asymptote. A horizontal asymptote is going to be an equation of a line. But this time it's a horizontal asymptote, so that's going to be a y equals. So my equation is going to be y equals a negative. Now, as far as how do we write this with limits? Well, we're just still going to do the limit as x approaches negative infinity like we were doing before with our end behaviors, moving left on the graph forever, and it's going to approach negative 1/2. The limit as x approaches infinity, which means we're moving right on the graph forever, that is still going to approach the negative 1/2. So this is still our end behavior notation. It's the limit as x is approaching negative infinity, which means we're going left forever, and x is we're approaching infinity, means we're going right forever. All right, so let's look at the next example. Okay, rule number 2. If the degree is smaller on top and it's bigger on bottom. So once again, we're still talking about the degrees of the polynomial. This is going to be your x-axis, or y equals 0. That is going to be your horizontal asymptote every time. So here's an example for it. Say we have 5x minus 9x squared plus 13 all over x to the 6. The number of terms doesn't matter when it comes to the degree of the polynomial. What matters to as far as the degree of the polynomial is the highest exponent. So on the top, when I look, my largest exponent is a 3. So this is a degree 3. My polynomial is a degree 3. On the bottom, this is x to the 6th power. So that's a 6th degree polynomial. Well, then I ask myself, well, which one's bigger? 6 is greater than 3. Therefore, my horizontal asymptote is just simply my x-axis, or y equals 0. And the way that we would describe this with limit notation is the limit as x approaches infinity of my function f of x. Well, that's just going to equal 0. And then the limit as x approaches negative infinity of f of x, well, that's just going to equal 0. All right, rule 3, here we go. Rule 3, if the top is bigger than the bottom. So in this case, we're still talking degrees of polynomial. If my degree, the degree of the polynomial on top is larger than the degree of the polynomial on the one in the denominator, my horizontal asymptote does not exist, but we will have a oblique / it's a slant. They're called the same thing. Oblique and slant mean the same thing. Asymptote, which we will have a different video on how to find the oblique and slant asymptote, because we will do that too. So if my degree on top is larger than the degree on bottom, horizontal asymptote doesn't exist, but we do have an oblique asymptote. So let's look at an example. So if I have something like x to the 13th over 5x squared plus 9x plus 4, well, we know the number of terms doesn't matter. It's just the degree of the polynomial, which is the highest exponent. My highest exponent on top is 13, so my numerator has a degree of 13. My highest exponent in the denominator is a 2, which means that my degree of the polynomial on the bottom is 2. Last time I checked, 13 is greater than 2. Therefore, we're in this bigger than smaller, and my horizontal asymptote does not exist. And in other videos, we will show you how to find the oblique asymptote. So in summation, we have 3 rules. We have rule 1, when my degrees are the same. It's going to be a ratio of leading coefficients. All right, rule 2. Let's see. If a numerator is smaller than my denominator, and we're talking about the degrees of the polynomial, my horizontal asymptote is going to be y equals 0 or x-axis. Same thing. This is the equation of it. This is the name of it. Rule 3 is if my numerator is bigger, the bottom, which is then going to be smaller, it does not exist. D-N-E does not exist, but we'll have an oblique / slant asymptote, which we will deal with later. And that, ladies and gentlemen, is how you find horizontal asymptotes. It's just 3 rules. That's it. No fancy math, nothing special, and nothing crazy. Just look at the rules, figure out what it is, boom, you're done. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.